Assalamualaikum warahmatullahi wabarakatuh. My name Herman from Universitas 11 Maret. Today I would like to share our research. The title is an experimental study into the effect of fuel and type of step microcombustor on the flame stability characterization. This is our collaboration research between Universitas 11 Maret and UTM Malaysia. So this is our team. Next, we're going to the introduction. Why micro power generation recently received a lot of our attention? Because as you know, almost all the electronic devices now become the smaller and then portable and likewise. So there is need the power source. This is the reason why the micro power generation become the interesting field of research for the researchers, especially in the combustion area. Because the one of the important part from the micro power generation is micro burner or micro combustor. This is the one of important part because from the micro burner or micro combustor, heat source will convert to the electricity energy. In our study, in this research, the effect of the fuel and then the type of the microcombustor we study and detailed investigation. And then this is our research methodology. So first, before we conduct the experiment, uh, we, we conduct the numerical simulation in order to have the optimum parameter because many parameters affect to the combustion processes, especially how to get the stable flame inside of the microcombustor. After we have the optimum parameter, we going to the experiment. This is our experiment apparatus and schema. So we have the compressor to generate the air. From the compressor, we have the air, and then the air flow rate will be controlled by the mass flow controller. And then fuel. In this experiment, we use the two type of fuel, propane and acetylene. And the mass flow from the fuel controlled by mass flow controller before intake to the microcombustor. And we observe the effect of the fuel and then the type of the microcombustor. This is our three type of microcombustor. They are type 1, type 2, and then type 3. So this figure show the comparison size between our microcombustor with the 500 rupees. So the important thing, first we investigation the effect of the unburned region and then burned region. And then we also observe the influence of the fuel, propane and acetylene. So this is the result. From the simulation result, we can predict the temperature. So for example, this is the maximum condition for the microcombustor with the burn region area or burn region length 10 millimeter. So this is the temperature result. And then this is for the burn gas region to 20 millimeter. So this is the result. This is the optimum result for the combustion microcombustor type 1, and this is the maximum result for microcombustion type 2, and this is the microcombustion result, optimum result for the microcombustion type 3. Okay, and then after that we have the optimum parameter from the numerical simulation. So we're going to the experiment. So this is the experiment result. This is the propane fuel, and then this is the acetylene fuel for the microcombustor type 1. In this figure, explain the influence of the or the effect of the fuel to the temperature. Where we observe the temperature, because temperature is important in order to convert from the heat to the electrical energy. So we have, if we use the dot of green color is propane, and then the dot of red is acetylene. So the maximum temperature of stable flame by using the acetylene around the 137.69 degrees Celsius. And then for the propane is more higher than acetylene, 155.88 degrees Celsius. However, we can see from the figure, the propane fuel have the result blue flame, but for the acetylene, there is the red one color. It's mean the temperature, and then the condition is, I think, can be explained if the propane is more quite high than acetylene. And then this is the result of the step microcombustor stainless type 2. This is the result of the temperature. From this result, acetylene have the temperature higher than propane. So this is interesting if we compare with the type 1. The difference of the length of burn gas region, we know the information from this experiment result have the influence between the propane and acetylene. And if we're going to the microcombustor type 3, and then type 2, the difference is type 3, the burn gas region is 20, but the unburned region is 30 millimeter. So type 3 have 40 millimeter for unburned gas region. So this is the difference between type 2 and then type 3. So we can see the result. The result have this similarity. The propane is lower. Also, this propane is lower than acetylene. But from the three type of the step microcombustion, so we have the description which one have the blue flame and stable flame more better than in microcombustor type 1, type 2, and type 3. So the result of the study inform if the propane can produce the blue flame, but the acetylene, like the characteristic of acetylene gas, so the little bit difficult to have the blue flame. So this is one of the example from the propane. So the stable flame can produce in the microcombustor, all the type of microcombustion. So what's our conclusion? The result of the study indicated that acetylene fuel has the stable flame slightly higher temperature than propane fuel. However, for the step microcombustor type 1, there is no difference in the temperature of the stable flame. And then propane fuel produces the blue flame compared to acetylene. Therefore, propane fuel is more suitable as the microcombustion fuel than acetylene because it is more stable and then does not form the tongue of flame outside the combustor. And then the length of the unburned and burned region also influence the flame stability characterization. So this is our conclusion of our study. And then we would like to thank for the Universitas 11 Maret for the support for funding for this study. And we also thank to the UTM, to the Dr. Fudel. This is our partner to conduct this experiment. So thank you very much. And if you have the question, I'm very happy. Or if you have the suggestion, please inform me. Thank you very much. Assalamualaikum warahmatullahi wabarakatuh.